Hey everyone, it's Dr. Jess. Welcome and welcome back to my channel. In today's video, we're going to discuss rate of reactions and which factors can affect the rate of reactions. If you like this type of content, please don't forget to like the video, subscribe to the channel, and turn on your notification bell so you don't miss out on any new uploaded videos. Okay, let's get started. Before we even talk about the rate of a reaction, we first need to cover the three conditions that are required in order for a chemical reaction to occur. So the first condition is that the molecules of the reactant must come in contact with each other. So they have to collide. The second condition is that the molecules of the reactant have to be in proper orientation or proper alignment. The third condition is that the collision must provide the activation energy. And the activation energy is the minimum energy required to break the bonds between the atoms of the reactants. So, a simpler way of explaining the concept of activation energy is to use the analogy of climbing a hill. So, if you're climbing a hill, in order to reach your destination on the other side, you first have to have the energy to climb to the top of the hill. So, that energy that's required to get to the top is our activation energy. So if you're at the bottom of a hill and the more energy that is required to get to the top of the hill, the harder the harder it will be for the reaction to occur. So for example, if we look at the picture on the right hand side, at the starting point, at the bottom of the hill, we have our reactants, and then we need the activation energy to get to the top of the hill. Let's test your understanding to see if you understood the concept of activation energy. So, true or false? Reactions with low activation energies go faster than reactions with high activation energies. Type either true or false in the comments below. Now, let's talk about the rate of a reaction. So the rate of a reaction is how fast the reaction goes. And that is determined by measuring the amount of a reactant used up or the amount of a product that is formed in a certain period of time. There are certain factors that can affect the rate of a of a reaction, and those are changes in temperature, changes in the concentration of the reactants, or by adding a catalyst. So next we will go over how each of these factors affect the rate of the reaction. Let's look at how temperature affects the rate of a reaction. If you increase the temperature, the rate of the reaction will also increase. And that is because if you increase the temperature, then there is an increase in kinetic energy of the reactants. So that means the molecules of the reactants will move faster and they will collide more often. So all of that will cause an increase in the rate of the reaction. Now, let's look at the effect of the concentration of the reactants. So, if you increase the concentration of the reactants, the rate of the reaction will also increase. Can anybody see why that is? Well, if you increase the concentration of the reactants, that means you have more molecules. More molecules of reactants means more collision. More collisions means that the rate of the reaction will increase. Lastly, let's talk about the effect of adding a catalyst. So previously we talked about the activation energy. which is the minimum energy required to break the bonds of the reactants. Now, let's picture this, right? Let's say that a collision provides less than the activation energy. So we know that if the collision provides less than the activation energy, then the reaction does not occur. Now, by adding a catalyst, the catalyst will lower the activation energy. So then by lowering the activation energy, then now the collisions then provide enough energy for the reactants to form products. So by lowering the activation energy, then the rate of the reaction will increase. So adding a catalyst will increase the rate of the reaction. And again, why? Because it decreases the activation energy, it decreases the amount of energy needed for the reaction to occur. So it becomes easier for the reaction to occur. So that means the catalyst will increase the rate of the reaction. Let's look at a practice problem. Look at the reaction and let's talk about how the rate of the reaction would change if you A, add some sulfur dioxide. So in this reaction, what are our reactants? So our reactants are sulfur dioxide, SO2, and then oxygen. So if you add some sulfur dioxide, that means you add more reactants. So that you increase the concentration of the reactants. So like we talked about before, what happens when you increase the concentration of the reactants? The rate of the reaction will increase. So A, the rate of the reaction will increase. B, if you increase the temperature. If you increase the temperature, we said that the molecules will move faster, more collisions, and the rate of the reaction will increase. C, if you add a catalyst. We just talked about this. If you add a catalyst, it will lower the activation energy and therefore will increase the rate of the reaction. D, if you remove some oxygen. Now you're lowering the concentration of the reactant. So what happens if you lower the concentration of the reactant? So you have less molecules, less collision happening, so the rate of the reaction will decrease. So D is decrease. That's it for today. Please don't forget to like, subscribe, and turn on your notification bell. I'll see you in the next one. Bye.